Today, in this speech, I am going to talk about a platform created in our laboratory regarding nanoemulsion formation by using polysaccharide for delivery of nutraceuticals. All of us sitting here are very much well aware about nutraceuticals, and probably COVID has taught us about the importance of nutraceuticals in our daily food or daily basis. And nutraceuticals are obtained from across different fields. They can be obtained from microbes as well as from phytochemicals. And they have an inherent property of instability. They have inherent property of bad taste and sometimes odor also. So we wanted to address this problem by using polysaccharide-based nanoemulsion. Now, next slide. Why polysaccharides? Next slide, please. Polysaccharides, we all are aware about it. They are basically a polymer composed of sugars, different kind of sugars linked to glycosidic linkages. And they have been, and they are naturally obtained from several sources, like plant sources as well as from microbial sources, very complex in structure with high molecular weight and extremely stable even under harsh environmental conditions. Now, I am specifically talking about microorganisms, microbial polysaccharides. Our lab mostly work in the area of microbial polysaccharide, both for process development as well as application development. Now, we found that these polysaccharides are actually natural, biodegradable, non-immunogenic in nature, and many of them are USFDA. They have found diverse application in food, biomedical, therapeutics, and other things. We can create different kind of materials like hydrogel. I have discussed in the earlier pitch. We can create polymer foams, we can create nanoparticles, we can create emulsions, and we can actually incorporate stimuli responsive behavior. All these advantages of polysaccharides actually pushed us, can we create a nanoemulsion of this material? Next slide, please. Now, nanoemulsions are the target of this nanoemulsion, formation of this nanoemulsion is to encapsulate the nutraceuticals for targeted delivery of them. Now, these nanoformulations are expected to improve water dispersibility and reduce volatilization, as well as it will enhance the stability of the molecules, reduce the undesirable flavor and taste. It can be controlled release also, and it will not have any adverse effect on the functional foods. Now, these different polysaccharides are actually used for making such kind of nanoemulsions. Next slide, please. When you looked into nano encapsulation market, the market is a bit niche even yet, but it is developing faster. It is around $7.8 million in 2021, and CAGR is impressive, 8.3%, and expected to reach around 14.76. The major driving force is again increased solubility, which will finally lead to higher bioavailability. It will enhance the shelf life, as well as help in controlled release of the bioactives. There are many global players, Cargill, BASF, DuPont, etc., etc. So there are many things many companies which are actually participating in this. Next slide, please. Now, I believe that nutraceutical companies who are using as at present synthetic emulsifiers and may have interest in using biological materials of biological origin, which are biocompatible as well as safe for towards green consumerism, where we will actually mask undesirable color, flavor, and taste, and as well as enhance the bioavailability as well with functional and storage shelf life improvement, especially for in case of processed food. Next slide. So next slide, please. Sorry, the earlier one, jumped one. Yeah, I've talked about it. Next slide, please. Next slide. Sorry. So now, when we look into this system, so we tried to pick up a model molecule. We picked up curcumin. We all know about the curcumin right now. And curcumin has the ability to scavenge anti-ROS, as it can be used as antioxidant. And so we just used curcumin as a model compound. We have used a few other molecules also for the same purpose, but today I'm presenting only curcumin here. So this curcumin is insoluble in polar liquids. So we have to make it solubilize in non-polar liquids. That's why probably curcumin is suggested to be taken along with milk. Now, curcumin emulsions are being formed using synthetic emulsifiers like twins. And in the current study, we have tried in polysaccharides. Now, if you look into the data in the bar graph here, you will see normal curcumin antioxidant activity is 61.5%. Whereas this is DPPH method we have used, and if we go for twin 80, when we put the activity actually reduces to 60.92%. Whereas when we used guar gum and leaven, two very well-known polysaccharides used widely in food industries, we were able to enhance the antioxidant activity to 74% in both the cases. We are just showing the data here because we have evaluated several polysaccharides in this range, and we are just reporting the best one. So we felt that this will be a good option. Next slide, please. So we have done it already in the lab scale. We have stabilized this emulsifier, and this is a first of its kind study where we actually evaluated efficacy of different polysaccharides for emulsification of curcumin without using any kind of co-emulsifiers. Few of the representative publications from our group are here. Next slide. So as I told you earlier, also CSIR-IMTECH is a national laboratory forerunner in the domain of microbial biotechnology. We have excellent facility for all kind of microbial technology, especially in terms of fermentation and bioprocess. We have a scale-up facility till 1.5 kL, 1,500 liter fermenter, and we pretty closely work with different industry. You can see here we have worked with different leaders in Indian industrial sectors, along with ISRO also. And so we are pretty industry friendly. Next slide, please. Our group mainly works in the area of bioprocess development, and we have successfully delivered several industrial projects like Panacea Biotech, IFB Agro Industries, Rampur Sugar Mills, Excellus Biotech, and Polymers. We are mostly focused in the area of fermentation, that too specific for microbial polysaccharides and some enzymes. Manoj looks after the business development part, and this work is done by Richa and Nandita. Next slide, please. So this is a platform what we have created. We can actually tailor-made this kind of platforms as per the requirement of industry, and we will be ready to listen to the requirement of the industry and place ourselves accordingly. The next step is to identify industrial partner for co-development for proving its techno-commercial viability in the next stages. Next slide, please. I thank Dr. Kavita for all her assistance. Thank you.